Hey guys, Christian here. Another graphing question today. Now I know it's been a bit of a theme this week, but these graphing questions are really going to make or break you, and when we sort of get up to this phase, exponentials and logarithms are ones that you rely on quite heavily. So we're just going to make sure that you guys get plenty of practice doing as many exponential and logarithm graphing equations as you possibly can. So today we've got a logarithmic equation that we're going to graph, and honestly it's quite an ugly one. But it's not as bad as it seems once you realise that the only things that make it ugly are negative signs, which just represent transformations. So whenever you're graphing an exponential or a logarithm, there are a couple of things that you want. You want the overall shape, you want the asymptote, and you want the x and y intercepts if they both exist. Now with exponentials, there's always a y-intercept, there might be an x-intercept, and with logarithms, the reverse is true. There's always an x-intercept, there might be a y-intercept. So let's start with the piece that's going to give us the most information as fast as possible, and that's the asymptote. So when you're trying to find the asymptote for a logarithmic problem, the easiest way to do it is to pretend that the argument was to equal 0, almost like a null factor law type deal. So if we just assume that minus x is equal to 0, then that would mean that x is equal to 0. And that's your asymptote. It's actually really straightforward. Logarithms will always follow this rule. You can basically take out the argument of the log and use null factor law on it, and whatever comes out at the end is the equation for the asymptote. It's really quite pretty. Moving on from that, let's have a go at working out the x-intercept. So when we work out the x-intercept, we always do it by making y equal to 0 and then rearranging the problem. So at present, we've got 5 minus 3 log e of negative x equals 0, right? And we're just going to use algebra to basically rearrange that. So we'll have negative 3 log e negative x equals negative 5. And then I'm basically just going to get rid of both of those negative signs to make life a little bit easier for me. Once you've done that, I would divide by 3, which gives you log e of negative x is equal to 5 on 3. And at this point, you have to start thinking about using the index form or the log form to try and manipulate what you want. So this is log base e, right? So the trick here is to use base e on the other side, and that will cancel it out. So I'll have negative x is equal to e to the power of 5/3, which means that just x is equal to negative of that expression. And now we've got our x-intercept. So we've got our x-intercept, which is negative e, 5 on 3, and 0. Now, if you need to find exact placing for that, I would advise using a calculator to get a decimal expression, but don't actually write that decimal expression when you're graphing. You always want to give exact values. We'll also have a quick look for a y-intercept, just to see if we can find something. Now, there may or may not exist a y-intercept, so we just have to try it. So if we make x equals 0, we would have 5 minus 3 log e of 0. Now we know from experience that we can't take log of 0, so therefore there is no y-intercept. Right? When you hit a roadblock, especially one involving domain, that usually implies that whatever you're looking for doesn't actually exist. Finally, just the general shape. Most logarithms have a sort of shape where you start with a vertical asymptote on 0, and then you go up. But this is special. This has got not one but two reflections. It's got a reflection here. Now, a reflection in front of the entire log expression is the same as reflecting in the x-axis, or from top to bottom. And this, a negative sign on the x term specifically, also represents a reflection in the y-axis. So this has been flipped twice, once from top to bottom and once from left to right, which gives it a very different shape. If we flip just from top to bottom, we would find a shape that looks something like this. But then once you flip it from left to right as well, you're looking at something more like this. So that's the shape that we're going to use for our graph, and now we're just going to put it all together. So, nice big grid, hopefully with nice neat ruled lines for you. X, Y. We'll mark in our asymptote first of all, which is x equals 0, which is here. So make sure, even if it's on the axis, you mark it very clearly, like in a different color or something like that. So it's very obvious that you've done that on purpose. We'll also mark in the x-intercept. We don't have a y-intercept, so we won't be marking that in. But the x-intercept is negative e to the power of 5 on 3. Now, based on the shape that I know and where my asymptote is, I'm just going to take a stab and say that the asymptote is about, the intercept is about there. And I'll mark it. Now, if you had your calculator on you, you could use the calculator to find a decimal value for this expression, and you'll find I'm not that far off the mark. But a lot of the time, if you don't have the calculator available, just use the context that you've been given. Between the shape and the asymptote and all these other bits and pieces, you should have a relative idea of where your intercept should be in the grand scheme of things. No y-intercept, so all that's left to do is actually graph the curve. And that's it. All there is to it. Now make sure when you're graphing, you don't touch that the asymptote. It's actually really important, and a lot of teachers are very, very fussy about it, because asymptotes by definition do not ever touch the curve. Guys, that's it for today's video. I hope you enjoyed. Thanks very much for joining me, and I will see you on tomorrow's video.